Hello viewers, in today's class we are going to solve yet another important and very conceptual problem from definite integrals involving the signum function, right? And here we have a very interesting problem, and this problem is also going to be very useful for the beginners, right? So let us start. So here we have to find the value of this integral, that is from minus pi by 2 to pi by 2, and the integrand is x times sine inverse of signum of x minus pi by 3, right? So let us call this integral as I, right? Now see, in these type of integrals, what we usually do, we make use of the definition of signum function, right? So here we'll exploit the definition of a signum function to reduce our integrand into a simple function, right? So let us start, and let us first quickly revisit the definition of signum function, right? Now see, signum of x is defined like this, that is signum of x is equal to plus 1 whenever x is greater than 0, and signum of x is 0 whenever x is equal to 0, and signum of x is minus 1 whenever x is less than 0, right? Now see, here we have signum of x minus pi by 3, right? So here our input is x minus pi by 3, right? So we'll apply these inequalities and this equality to this input, right? So signum of x minus pi by 3 remains plus 1 whenever x minus pi by 3 is greater than 0, right? Or in other words, we can say that x is greater than pi by 3, right? Now similarly, signum of x minus pi by 3 is 0 when x is 0. So here for x we have x minus pi by 3, right? So x minus pi by 3 is equal to 0. It implies x is equal to pi by 3. So here we have an equation, right? And signum of x minus pi by 3 is minus 1 when x is less than 0. So here for x we have x minus pi by 3. So x minus pi by 3 should be less than 0, right? So if we solve this inequality, we'll get x less than pi by 3, right? So now here we have the number line, and the lower limit is minus pi by 2 and the upper limit is pi by 2, right? So let us represent some important values of x on this real number line in order to get the picture clear, right? And see, here between minus pi by 2 and pi by 2, we have this point, that is x is equal to pi by 3, right? So this point x is equal to pi by 3 is the point where we split this integral I into the sum of two integrals, right? So we can now write I1 plus I2, because see, all the values of x which lie towards the left of pi by 3 are less than pi by 3, right? And all the values of x which lie towards the right of pi by 3 are greater than pi by 3, right? So this portion is x greater than pi by 3, and this portion is x less than pi by 3, right? So now we can write our integral as minus pi by 2 to pi by 3, right? So first we'll go from minus pi by 2 to pi by 3, and the integrand is x times sine inverse of signum of x minus pi by 3, right? So since we are integrating from minus pi by 2 to pi by 3, and when x is less than pi by 3, then signum of x minus pi by 3 is minus 1, right? So here we'll write minus 1, and here we have dx, and then from pi by 3 2 pi by 2, right? So now we are integrating from pi by 3 to pi by 2, and we have x times sine inverse of signum of x minus pi by 3. Now in this case, all the values of x are greater than pi by 3, right? So signum of x minus pi by 3 takes the form plus 1, right? So this is the important point while integrating these type of integrals involving important functions like greatest integer function, signum function, fractional part function, or the absolute value function, right? So now we have these two simple integrals to evaluate, right? Now from inverse trigonometric function, we know that sine inverse of minus 1 is minus pi by 2, because sine of minus pi by 2 is equal to minus 1, right? And sine inverse of 1, that is plus 1, is simply equal to pi by 2, right? So now we can write minus pi by 2 to pi by 3, and here we have x times sine inverse of minus 1, so this is minus pi by 2, right? And here we have pi by 3 to pi by 2, and here we have x times sine inverse of 1. Sine inverse of 1 is simply pi by 2, right? So now we can take this minus pi by 2 outside the integral, and we have minus pi by 2 to pi by 3, and the integrand is simply x, right? So the integrand is now simply x, and here we have pi by 2, and taking pi by 2 outside the integral being a constant, and here we have pi by 3 to pi by 2, and here we have x dx, right? So now we have I is equal to, here we have minus pi by 2. The integral of x is simply x square over 2, right? Because here the exponent is 1, and we are using this result, that is x raised to n dx is x raised to n plus 1 divided by n plus 1, and provided n is not equal to minus 1, right? So here limits of integration are from minus pi by 2 to pi by 3. Then here we have pi by 2, and again here we have the exponent 1. So we have x square over 2, and the limits are from pi by 3 to pi by 2, right? So now we can write I is equal to minus pi by 2, and here we have 1 over 2, that is x over 2. So we can take half outside, and x square limits are from pi by 2 to pi by 3, and here again we can take this 2 outside. We have pi by 2 half and x square, and pi by 3 to pi by 2, right? So this is minus pi by 4, and when we take x is equal to pi by 3, so here we have pi square over 9, because substituting the limits and taking the difference, right? And then we have here minus sign, and when we take the square of minus pi by 2, it becomes positive pi square over 4, right? And here we have pi by 4, 2 times 2 4, and when we take x is equal to pi by 2, here we have pi square over 4 minus here we have pi square over 9, right? Now let us simplify this expression. So we have minus pi by 4, and here we have 4 pi square minus 9 pi square divided by 36, taking the LCM, and here we have pi by 4. Again taking the LCM, we have 9 pi square minus 4 pi square over 36, and now 4 pi square minus 9 pi square is 5 minus 5 pi square over 36, and here we have pi by 4 times 9 pi square minus 4 pi square is 5 pi square over 36, right? So now minus times minus is positive. Multiplication of these two terms gives us 5 pi cube over 144. And here also we have 5 pi cube divided by 144, right? So this is 2 times 5 pi cube over 144, right? So this is 272 144. So this is 5 pi cube over 72, right? So viewers, the value of this integral is 5 pi cube over 72, right? So this is how by making use of the definition of signum function and applying the various tools of definite integrals, we can evaluate these type of important definite integrals.